We're excited to announce our new Dreambooth Training API available for Stable Diffusion 1.5 and Stable Diffusion XL. With this family of APIs, you can easily train a LoRa model on any subject. For this tutorial, we're going to use the Stable Diffusion XL Dreambooth API. I'm going to train a LoRa on my face and then demonstrate using it in ComfyUI. The only tools you'll need for this tutorial are Postman for API interactions and ComfyUI or the Stable Diffusion user interface of your choice, as long as it supports LoRa's. Before we dive in, I want to go over a few terms that we'll be using. First, LoRa. What does it mean? It stands for Low Rank Adapter, and at a very high level, you can think of it as a plugin or extension for the base model. It's a much smaller file than the base model, and while the base model contains the general knowledge of image generation, the LoRa contains the specific new concept that you trained. Dreambooth. Dreambooth is a training technique developed by Google to teach a new subject to an image generation model with a relatively small number of sample images. What do I mean by relatively small? You'll find tutorials and documentation recommending as few as 3 images, but I have always had better results with 20 to 50 images. I'll be using 33 for this tutorial. When you compare this to the billions of images it took to train the base model, you'll see why we call a few dozen small. API. Application Programming Interface, meaning this is primarily intended to be used programmatically and not directly by end users. So to summarize, we're going to use the Dreambooth API to submit a Dreambooth training job, resulting in a LoRa file that we can use in ComfyUI. Okay, now let's get started. We don't technically need this page in the portal for anything, but it does have this API URL and some documentation on using the API. We won't be using the API from here though. For that, we'll be using Postman. First though, we have to upload some pictures of me to use in the training. Here I've gathered 33 photos of myself. Ideally, your photos show you in a variety of poses, a variety of expressions, and in a variety of settings. This variety helps the model learn to generalize. Unfortunately, almost all of my photos are selfies, and that is probably going to impact the quality of the final model. We'll have to wait and see. Okay, let's zip up all these to make uploading them a little simpler. Gonna just select all, compressed zip file. There we go. Gonna name it Shawn Photos. Nice and obvious. All right, and now it's time to upload. Okay, here I am in Postman. I've got my Salad API key saved in a variable, and I've used the authorization section here to tell Postman to add my API key to every request in the Salad API key header. Okay, so we're going to use the Salad Storage API to upload my photos, but you can use any service that provides a public download URL for your file. In the URL here, you can see we're going to upload this to Dreambooth tutorial stuff / shawnphotos.zip within my organization's file storage. The body is a form data type of body, and we're going to set key here file with the type of file, and we can do a new file from local machine. And there we've got my zip file. We also are going to set the MIME type, which is application xzip. And we're going to sign the URL so that it can be downloaded without further authentication. Okay, I'm going to go ahead and get that uploading. Okay, you can see we've gotten back a URL, and at the end of that URL, it says token equals and this random ID. That token is what allows the file to be accessed without any additional authentication. Okay, now don't lose that URL because we are going to need it in the next step. Finally, time to submit the training job to the API, and we're going to do that with a post request to the endpoint. The URL here I copied directly from that endpoint page we saw earlier, and this JSON request body I modified from the example in the README. The model and type fields are pretty self-explanatory, so we're just going to dive straight into the parameters. First, the instance prompt. This should be a short statement that describes all of your instance images. In my case, we're going to use photo of Shawn. I'm using this shortened all caps version of my name because I want to provide the model with a new word, also known as a token, to associate with the new concept I'm teaching it. You want this value to be pretty unique and to not have much meaning to the base model. So next, instance images. All of our images are in that zip file we uploaded, so we're just going to put that URL we got from the previous step here in this instance images array. We want to train for 5,000 steps at a learning rate of 1 times 10 to the negative fourth power. We are going to use prior preservation, which is a technique that helps the model remember the general class of image that you're training on. For instance, since I'm a man and my instance photos are all photos of me, I'm going to use the class preset photo of a man. You can see the full list of presets in the documentation. If you don't want to use our presets, that's no problem. You can just include your own images in a class images field like we did with the instance images and set your own class prompt to describe it. There's more details on this in the documentation. We are also going to train the text encoder, which can often improve accuracy of the final model. The API does support webhooks, but we won't be using them for this tutorial. Okay, we're ready to hit submit. And here we go. Now we've gotten back a response, and that includes this ID of the job. We are going to need this value later to retrieve our trained model and check the status on it as it trains. So I am going to go ahead and save this response to a file so that I don't lose it. Okay, now that's going to take quite a while, probably about 4 hours based on our average training speed. So we'll come back to it then. And we're back. It's probably been long enough, so I'll go ahead and check the status of the job, again using Postman. You can see this URL is the same URL we used to submit the job, but it's a GET request and with the job ID appended to the end. So we're going to go ahead and send that. All right. Okay, now in this response, we can see that the status of the job is succeeded. And then we've got this output field here. And in that output field, we have 2 download URLs for the model that we trained. We provide the LoRa in 2 different formats, one for diffusers and one for almost everything else, like, ComfyUI, Automatic 1111, etc. We'll be using the web UI link to download our weights to use in Comfy. Okay, now I download the file, and I'm going to name it something easy to remember and that includes that special token in it so that I'll be able to remember the token later when I'm generating images. Okay, it's done downloading. What really amazes me is how small this file is. It's only 28 megabytes, while the base model is about 6.5 gigabytes. It's time to test out our model, so I've opened up ComfyUI. I've already put that safe tensors file we downloaded in my ComfyUI LoRa directory and set up my normal workflow for an SDXL plus refiner image generation. You can see we've loaded up that LoRa file that we downloaded previously, and you can see I'm using a pretty simple prompt, but it does contain that special token value. So let's queue up a few images and see how we did. And there I am. Not too bad. Pretty good likeness overall. All right, that's it, folks. I hope this has been helpful. Go train some models.